Example number 8 asks us to suppose, well, actually I shouldn't say, this is the question right here for example 8. This right here is a contrapositive of the intermediate value theorem. And so basically it says, look, let me draw out what's going on here. It says, okay, if you've got a situation in which you've got, I don't know, some point here, okay, for your starting of your interval. Let's call this A. And we've got some point here for the end of our interval. I don't know, call it B. And we know that over this interval, we never hit, I don't know, some height, call it C. Okay, if the function's continuous, okay, and f at A, which is this guy, is less than C, then f of B also has to be less than C. So basically what it's saying is, look, if this guy right here is continuous, who knows what it looks like, okay? If it's continuous and it never takes in the value C, and one of the endpoints is either above or below that line, then the other endpoint is also above or below that line, okay? So the question is, and this was not as used, in my opinion, as the straightforward intermediate value theorem, but let's go ahead and try to take a look at a problem here. So suppose that f is continuous on some interval. Okay, so I'm going to draw out the interval. Here's 0. Here's 3. I don't know what the function is. I just know it's continuous on that interval. And I also know, though, that it has no roots, meaning it never crosses this axis. Okay, and additionally, the function at 0 is up here at a height of 1. We need to show that no matter where we pick, okay, any value, that we're always above the axis. We're always positive. Well, let's pick an arbitrary value in here. Let's just call it B. And let's show that no matter what, f of B is greater than 0. If we show that for all B on the interval from 0 to 3, then that implies that f of x is greater than 0 for all x in 0 to 3. So look, well, what do we got here? Let's just take this interval right here. Okay. Well, clearly f of 0 is greater than let's write it again. F of 0, which is 1, is greater than 0. That's this guy right here. Okay. Now, we know that f is continuous, and since it's continuous on the interval 0 to 3, it's surely continuous on the interval 0 to b, where b is less than 3. Well, we can say less than or equal to 3. Okay. So since it's continuous on this interval, okay, so let's make sure we call this up. First of all, it's continuous on the interval, and we know that it never takes on the value 0 because there are no roots in here. So f of b is never 0 for all b in the interval, for all x, for all x, not for all b. Yeah, yes. For all x in the interval 0 to b. Okay. It's true that it never takes in the value 0, so we've now clipped this one for all the values in there. And we know this is the one we're looking at. F at this endpoint is greater than 0. That implies, all of this information implies that f of b is also greater than 0. And b was arbitrarily picked between here, so therefore f of x is greater than 0 on the interval in question. And that's it. That's all there is to it.